In the previous video, we got introduced to variables and we had a bit of a play around with integer data types. So it's now time to talk about different types of data types and more information about the integer data type. So I'm going to close this first project down by clicking on the red cross in the left-hand corner of the screen. And I'm going to create a new project. I'm going to select Java. I'm going to click on Next. I'm going to click on Create Project from Template. Click on Command Line App, click on Next, and I'm going to call this one Byte, short, int, and it'll make sense as we go through the video why I'm doing that. I'm going to change the base package to com.timbachalka, but you can change that to literally at this stage whatever you would like. Click on Finish. Now firstly, I want you just to check a setting before we go any further. I'm going to right click the project name here, and I'm going to go down to where it says Open Module Settings. I'm going to select that. And you want to make sure that this language level is actually set to 8, which is JDK 8. In the previous section, we installed the Java Development Kit version 8. So we need to set that to 8 to make sure we don't get an error as we go through this video. So click on OK. Okay, I'm going to double click main now to make a bit more space. And I'm going to start writing some code. And if you remember in the previous video, we created some code that did something like this. Int my value equals 10,000. So what that was doing was creating a variable called myValue of type integer with a value 10,000. And so in computing terms, the computer has allocated enough space to store an integer and it's assigned a name for that variable of myValue. But what actually is an integer? We know that it's a whole number, but what can we store in an integer? Like, is it an infinite number we can store in there? So in actual fact, in computing terms, normally there's always a limit as to what it can do. There's a minimum and a maximum. So with a data type int, the computer assigns enough space to store a number that is between the ranges of around about minus 2.147 billion to positive 2.147 billion. So in other words, a number that is in that range. If we try and use a number that is smaller than that range or greater than that range, we'll actually get an error. And that's because it physically won't fit in the space that the computer has allocated. And in that scenario, what you would use is you'd use a different data type for that particular type of processing that you want to do. And I'll be talking more through this course showing you which data types to use for particular scenarios. Generally speaking, the integer data type, I've introduced that to you first because that is the most common data type and you'll normally use that. That'll be your first variable. If you're looking to process something in whole numbers, you'd probably be using an int. But I want to show you some of the alternatives and just go through so you understand behind the scenes the minimum and maximum values that can be stored in this data type as well as other data types. So it turns out the minimum range, I'm going to delete that and put my min value for an integer is, I said minus 2 billion, so it's minus 2,147,483,648. So that is the smallest number that can fit in an integer. So we try and make it smaller still, like we make the 8 on the end of 9, we actually get an error, and if we hover our mouse, integer number too large. So that sounds a bit funny, you think that would probably should say integer number too small, but essentially what it's saying is we've tried to exceed the boundaries of the minimum and maximum values for an integer. Setting that back to the smallest acceptable number, and I'm just going to copy and paste this, and we'll create a second variable with a maximum value. The maximum value is, getting rid of the minus sign at the front, that's the maximum number, 2,147,483,647. So again, if we try and make that larger, we'll get the same error, integer number too large. So I'll set that back to what it was. So if you need to do whole number calculations, an integer will only work if you've got numbers that are inside that range. Now obviously for the computer to store a number that large or that small, takes a certain amount of space. Now just before I go on, I just want to make it clear that any number that you type here that you see that is a fixed number that you're typing in a statement like this when you're defining a variable, this part here to the right is called a literal. So we're typing in a literal there to the right and that's a fixed number. It wouldn't be a literal if you've done something like, you've created something like A times B and you had those variables that existed in your project. That would not be a literal, that's an expression. But where you're typing in a number like that, I've just done an undo, that is a literal. Now what you can do is you can change this, you can put underscores in there to make the number more readable. And this has been a feature that has come out since Java 7. And that's why I asked you to have a look at for the module settings when we went into that earlier in the video, because this would come up with an error unless you've set that module change to test to Java 8. So if you're typing in a literal, you can use underscores. That makes the number a lot more easier to read. So I suggest where you've got a large literal number that you're typing in like that, use underscores to make it more readable. So as I said, the integer is allocated a certain amount of space by the computer. Being efficient, if we want to do some calculations and we don't want to use a number that's within that range, we want to use perhaps a much smaller number, we can use a different data type. And Java makes available to us different Java types for different types of things that we might want to calculate. So the next data type I want to discuss is called a byte. So we can type this like byte. My byte value equals 10. So what we're doing there is we're telling the computer this is a data type of type byte, and we're assigning the value of 10. And the name, of course, we're defining is my byte value. Now, byte value is allocated by the computer a much smaller amount of space, and consequently, it can fit a much smaller number. In actual fact, a byte can only store a number in the range of -128 to 127. So literally, that is the smallest number that will fit in a byte, and the largest number that can fit is 127. So if we try and exceed that, we'll get an error. And likewise, if we try and make the number smaller than the amount of space, we'll get an error as well. So why would we ever want to use a byte? A byte is more efficient because it's in roundabout terms, it would normally take about a quarter of the amount of space of an integer. So if you've got a lot of calculations, it can be far more efficient to use a byte because the computer is not allocating as much space for a byte than it is for an integer. And particularly in situations where a computer hasn't got a lot of memory, or there's a particular type of Java program you're running, and particularly on mobile devices for argument's sake that haven't got a lot of memory, it does make sense to use the right data type for what you're trying to achieve. So that's a byte. There's also another one, which we call a short. And a short, the value for a short, we'll put my short value for the name. And this can store a larger number, at 30,000 for argument's sake. But the actual largest number that can be stored in a short is -32768. So we try and go smaller, we get an error. And the largest is 32767. And if we try and exceed it, we get an error. So again, that's a different type. And generally speaking, a short is allocated about twice the amount of space that a byte is, and about half the amount that an integer is. What I'm going to do is I'm going to put a space there, and I'm going to put what's called a comment. I'm going to put 2 slashes like that, and that defines a comment that we can just type something in there that is for us, and that command is ignored by the computer. So it's really great for documenting and making sense of a program to give yourself some notes that you can refer to later. So what I'm going to do is just outline what these variable types are. So we're going to put integer. It's good to think of an integer has a width of 32. A byte, 2 slashes again, byte has a width of 8. Short has a width of 16. So generally speaking, a byte is half the size of a short in computing terms, in terms of how much space has been allocated, and a short is half the size of an integer. That's 3 data types that are all based on whole numbers. There is one more data type, and that's of use where you've got a number that you want to process that is larger than the amount for an int. We call that a long. We put long, my long value equals 100. Now technically that's wrong, because when you're assigning a long value, you want to actually put the letter L on the end of it. And that tells the computer that this is a long value. You can put lowercase l or uppercase L. I suggest you use an uppercase L because that's a little bit easier to read than the lowercase l, which sort of blends in and looks like a 1. So in other words, that looks like 1001 if you don't look at it really carefully. But if you put a capital L, you can see clearly that that's an L and not 100. And long has a width of 64. So what that means, it's double the width of an integer. And the actual number that we can store, in the case of an integer, the minimum number was 2 to the power of 31, but a long value, we can actually store a huge number. It's actually 2 to the power of 63. So it's something like this. I'm going to paste the number in. I can't actually tell you what that number is, but it's actually a huge number. That's the minimum, that's the smallest possible number. And you can see that it's got 18 numbers after the 9, so 19 numbers in total. So it's a huge value. And the largest value is the positive version of that, -1. So it would be like that. So that's the largest possible number. They are the 4 data types in Java that deal with whole numbers. So when you're developing a program in Java, you would be deciding when you're using whole numbers as to which data type you'd be using to solve your particular problem. And as you work through this course, you'll see a lot of these data types in action, and you'll get more of an understanding as to which one to choose for a particular scenario. In general, as I mentioned, you want to choose the integer by default. So probably 9 times out of 10 or 8 times out of 10, you would go up here, you would choose your integer when you're dealing with whole numbers. Let's have a talk now about arithmetic in the different data types. In the previous video, of course, we did some basic arithmetic using the integers. We can do something just as a recap. We could come up here and we can put int my total equals my min value divided by 2. The forward slash is the divided by. So that's just a simple bit of arithmetic which takes the value of my minimum value, which is minus 2,147,483,648 divided by 2. No problems there. And with the byte value, we can put byte, my new byte value equals my byte value in brackets divided by 2. But we get an error. Now why do we get an error? Because that seems to be okay. In the case of the integer, we just defined it in brackets to be my minimum value divided by 2. But here we've got an error. And if you have a look at the error that's coming up on the screen, it says incompatible types required byte found int. So what it's saying is, well, you're defining a variable of type byte. So whatever you type on the right hand side should be a byte, should be of type byte. And when we type in a number that fits within the range of a byte, it accepts it, as you can see on the line, the minimum value. We haven't exceeded the minimum value, or we haven't exceeded the maximum. But when you type in an expression, because remember, something that isn't a fixed number, like in the case above, this is an expression, whereas the one above is a literal, because it's actually just a fixed number. And what's happening here is, this is the nature of Java, and what I was saying about how an integer is the sort of go-to or the default data type you should use for whole numbers. By default, when you're making an assignment in an expression, Java converts that to an integer. So what's happening here is, we're looking for a value that's of type byte to put into our my new byte value variable, which is type byte, but Java has converted that automatically to an integer. And therefore, it's now complaining and saying, well, I'm sorry, but that's an integer, and you're trying to fit an integer into a byte. And we know that an integer takes up a lot more space than a byte, so that number physically won't fit into the area of memory that has been assigned. This is just a weird thing that Java does, and what you need to do to get around that is you need to specifically say to Java, look, I want you to treat this as a byte. So to do that, we do something called casting. So we just put something in front of that. We just put in brackets byte. So what we're saying is, Java, I want you to treat that as a byte. And Java gets rid of the error and says, okay, if that's what you want to do, I've converted. I'm not going to make that an integer anymore. That's now a type byte. So therefore, my new byte value, which was a type byte, has been assigned a byte value. And we might just print some of these out just so we can see that we're on the right track here. And we can put something like my total equals, this is a way to print the value and print a bit of text there as well, plus my total. And we'll put my new byte value equals my new byte value. Okay, let's run that. And as you can see, looks like we've got the right results there. So that's correct. Likewise for a short, you need to also do the same thing. So we can't just put short, my new short value equals my short value divided by 2, because of course you'll get the same error. And the error is looking for a short and found an int again. Similar error, but this time it's the short. So we'd fix this one by typing short. Generally speaking, an integer is the way to go, and you can see that that is the case because Java by default, if you don't specify the type that you actually want, it converts it to an integer automatically. And that's why I would suggest that you always work, generally speaking, with an integer unless you've got good reason to not do that. Okay, so I'm going to delete that, and I'm now going to issue a challenge to you now that I've deleted that off the screen. So create a byte variable and set it to any valid byte number. It doesn't matter. Create a short variable and set it to any valid short number. Create an int variable and set it to any valid int number. Lastly, create a variable of type long and make it equal to 50,000 plus 10 times the sum of the byte plus the short plus the integer values. Okay, so pause the video here and go away and do that. And when you get back, I'll go through and show you how to do that. So how did you go? Did you figure it out? Well, let's make a start on that. So we will do something like byte. We'll call it byte value equals, we'll say it's 10. Short, that's our first variable. Our second variable, short value, equals 20. And int value equals 50. So how are we going to do the next bit? Well, the next bit would be long. We'll call this our long total. So we'll put long total equals 50,000 plus 10 times, and it's actually a lot easier than you'd think. It's byte plus short plus int value. It was a little bit tricky in that you don't need to enter the cast there because this is converting automatically to type long, and long will quite happily accept an integer. To be more precise, we could probably put an L there, 50,000 L plus 10L times the byte value plus the short value plus the integer value. You can print that out on the total, and if we run that now, we get a total of 50,800, and that's because it's 10 plus 20 plus 50, that's 80. So that's 50,000 plus 10 times 80 is 800, so that's 50,800. So a little bit of a tricky one there in that you didn't need to do a cast there. And the point I'm wanting to make there is with variables of type long or integer, you really don't need to do any casting like you do for shorts and bytes. If you put a value in a bracket for byte or short, it will automatically be converted to an integer, and a variable of type long will also accept an integer value. But of course, just finishing off, if we wanted to do this to a short variable, we could put short total. We might say it's 1000 plus 10 times, and then we put our byte value, short value plus int value. We're going to get an error there, and what we would do is we put the short here, and so everything we want to deal with there is going to be type short, and we then have to put another bracket there to make that a valid line. So it's basically saying everything in this bracket is to be converted to a short. So you can see that Java makes you do a little bit more work when you're dealing with variables of type byte or short. And the point I want to make is that using integer is the best one to use generally, but even if you are using type long, Java handles a lot of the complexity for you, and you don't have to do this casting because a long will happily accept an integer when you're defining a value to it as well. And just to confirm before we finish, if we print out short total, we'll run that. Short total was 1800, and of course that was 1000 plus 10 times 80, which was the sum of those three. 10 times 80 is 800. Total was 1800. So that's bytes, shorts, integers, and longs. In the next video, we're going to go ahead and start talking about decimal numbers, because of course to date we've only dealt with whole numbers, but there are scenarios where you want to actually go ahead and use decimal points. For example, converting pounds to kilograms or something of that nature where you want to deal with decimal numbers. So we'll go ahead and work on that in the next video.